were having a lot of problems shipping our oil down south. The oil would get as far as the border, and then it would get seized and quarantined, because the government down there didn't know what we were doing. We've had drivers go down there, and they were thinking they were just going to go and drop down a load of oil. They ended up seizing the truck, impounding the truck, and holding the driver over for the entire time. So that driver went down there and thinking he was going for a 6-day round trip. He ended up down there for over a month. Missing his family. His family couldn't contact him. It was a nightmare, really. And so right after that, can you guess? Weird, oddly enough, we couldn't find anybody who wanted to drive down there. Who wanted to? And one of the reasons why they did that is because not only did they not know what the oil was, they were held up doing the testing on every barrel that we did. They were finding discrepancies in between the barrels. There was nothing for them to work off of, basically. And if you send 10 barrels down, you got to do 30 tests on each one of them, and everyone's tripping over each other trying to figure out what's going on. It doesn't make for it makes for a very costly transfer. So Gary made it so that in the future, every farm connected with Young Living will have their own laboratory, their own first-person testing. I don't actually work for the mill here. I have to keep that separate just for that reason. There can't be a conflict of interest between my results and what the mill needs. So what I'm able to do now is create a certificate of authenticity that I can put into our shipment that guarantees for the FDA and the Border Control that is exactly what I say it is. Here's all my tests, here's all the results. If you find anything different, we can talk about that. I can actually get in a lot of big trouble, so I'm very careful about how I do that. So. Now we have a good working relationship with the border. We get a shipment down there. The latest it's ever hauled up is maybe 3 or 4 days, and then it's on its way. So it's a lot less cost, a lot less time lost. Gets onto the market faster, gets into their testing faster. Everything works a lot better. So yeah, the way I do that is the first machine here, my first line of testing is a gas chromatograph. Basically what that does is it pulls the oil apart and then calculates how much of each compound is in the oil. And it's that percentages of those compounds that fall within a specification of where that oil needs to be. You see up in the top here, this is all automatic. You see a syringe in there. It'll clean itself, take a sample of your oil. It'll put it down into a heated chamber. It's hot enough to vaporize the oil, turn into a gas. It's an airless chamber to make sure it can't combust. All the molecules stay in one form. And then that gas starts to run through the column. And those columns are measured out to 60 meters, so we have a precise measurement on how long it is. And then our detector picks up the charge at the other end, telling us how much there is. So we know how much there is going through the column and how long it gets there. And then what you end up doing is you end up building a retention table based on all these different compounds. The more you fill up that table, the more comprehensive your understanding of that oil, the better you are at detecting and identifying other compounds you're not familiar with. So it's a very, very useful tool for quantifying hydrocarbons. This is an FID type. It stands for flame ionization detector. What it does is it takes the carbon atoms and it runs them through an oxygen-hydrogen flame, which adds an ion to those carbon atoms. Those ionized carbon atoms come up through the detector and it reads that charge. And then that's how you get your quantification on your results. I'll show you more of that on Friday. We'll be running your oil through it. You'll get to see how the whole thing works. And you see the results that come out on the screen. So that there is a destructive test, what's called a destructive test. You put your sample in, it destroys it, it tells you what it is, it's non-recoverable, you're not getting it back. I do have some instruments here that take the physical properties of your oil. The first one there on the very left is a polarimeter. So I have a device there that I'll fill up with the oil. I'll insert it in there and it'll shine a bright beam of light through it. And at the other side, it will determine whether that beam of light is turning left or right, depending on its polarity. And the reason why that's important is because it's an indication of what's called chirality. If you take a look at a water molecule, you have 1 oxygen, 2 hydrogen. It's a very polar compound. They're all oriented on one side of the atom. But if you take a mirror image and you superimpose them, they're the same. There's no difference. But if you take your hand and superimpose it over your left, they're different. So that's a chiral molecule right there. And the reason why that's important is if anybody knows what the main ingredient in Vicks Vapor Rub is, mentholatum. It's a compound in there. It's got that really winter green, really cold feeling kind of thing there. If you turn that molecule, if you turn one part of that molecule 90 degrees, it's now methamphetamine.
Oh.
So chirality really matters in pharmaceuticals. One can heal, the other one can kill.
Oh.
So knowing the orientation of the molecules within the black spruce lets me know that if there's parts that don't belong there, as an indication that there's something wrong with the oil. It's either too heavy in the larger compounds, there's not enough non-polar compounds in there as it should be, and it gives me a determination of whether or not we can keep that oil. That center one there is a densimeter, and it's just like the name, it just measures the density of the oil. It's quite precise. It'll put that up to 4 decimal places, grams per cubic centimeter. It's quite accurate. That again puts me within a specification range of where oil should be sitting. Black spruce is typically 8.9 to 0.089 to 0.008. It has to fall within that range. If there's other compounds that are in there, it'll affect the density of the oil. If there's contamination with coolant or hydraulic fluid, that value will change, and then I have to look into it and do further testing. And again, puts that in a certain specification range. It's quite narrow. The one on the very right there is interesting. That's a refractometer. Again, using light. It shines a beam of light through the bottom of your sample, it reflects off the bottom, and it goes through the sample and reflects off the top. And what it does is it calculates the difference in speed of those two beams of light. And that'll put you in a range of a refractive index that has all known materials on there that's been tested through refractology. Again, it puts that into a range of where your oil should be. If it's outside that range, you have to try to figure out why. And if it doesn't meet all of these, it's not good enough to ship. So you'll find, well, at least I've found, that you could have 2 trees growing in the same environment next to each other. They could be the same height, they're going through the same weather events, they're using the same nutrients out of the ground, and chemically they'll be different. So one distillation is not going to be exactly like the other. We get it from slightly different areas, they're not exactly 100% the same. So I'm going to get distillations that are out of spec, constituency-wise. Their percentages will be out. And the way I fix that is I take another batch of oil that's out the other way, blend them together in a certain amount, and bring them back into spec. So by doing this, typically what I can do is I can blend the out of spec oil at the beginning of the season with the out of spec oil at the end of the season and come up with a whole oil at the end. So I haven't had to throw anything away. I have had to quarantine the oil a couple of times because I did get compounds that were coming out in the GC that shouldn't have been there. And we found out that there was a coolant leak out on the block there. So we ribboned it all off. We didn't log there anymore until it was all cleaned up. I haven't had any problems with hydraulic fluid yet. I'm still looking for that. Always keep an eye out for anything that's out of the ordinary. So that's the hands-on testing that I need to. All those values I have to be able to have on my C of A. It tells them that I've ran through the ISO procedures as outlined by Standards Organization of how I carried it all out. I have to keep everything in here very well calibrated. It's a lot of work, a lot of times. This one here is especially sensitive to contamination just from myself and my environment. If it gets too dusty, the detectors get dusty, you start getting varying results like crazy. And sometimes it could be a real challenge chasing down what the problem is. Yeah. When I first started out, I was hardly ever running the GC properly because I was always trying to figure out how I was messing it up. So, yeah, the first couple of years was a real challenge. I still have to get down to the United States to finish my training. Hopefully this year I'm going to be able to make it down there. I was supposed to be doing this for the duration of my time in here. Unfortunately, it just hasn't worked out, especially with COVID. That travel just wasn't going to happen. So I'm quite a few years delayed. But what I did have from Young Living's R&D department was all the help I could ever need. Every question I had, there was always somebody there, either online or on the phone, to walk me through, any question I've ever had, give me tips and tricks on how to do it efficiently. And I can't wait to get down there and actually finally meet these people. I was supposed to do that 6 years ago, but it didn't ever happen. So
I remember they said over 50 scientists in our lab for support.
Yeah, and once the oil leaves here, it goes to those 50 scientists, and they put it through 30 more tests. So yeah, this is just the tip of the iceberg here. This is more like, this lab is more damage control. To make sure there's not a catastrophic event down the line during transport and receiving. If you could imagine, it's actually happened to black spruce before. They ended up getting a whole batch of black spruce, an entire season's worth. It ended up being contaminated with groundwater that was carrying pesticides. And they ended up having to destroy the entire thing. You can't take it out, and you certainly don't want the public using that. What had happened is that there was an airport who had hired another company to go do a bunch of spraying. There was a beetle that was killing the trees. They had to do something. Somebody thought it would be a great idea to use this water-soluble pesticide, right? So save a few bucks, I guess. Ended up contaminating groundwater. Yeah.
Oh gosh.
Yeah, not very good at all. It's good to have that first line of defense. If that had gone through and somebody had missed it and they got it down the receiver, they never knew, mixed it in with another big batch of oil, to blend everything up, getting ready for testing, it would have been catastrophic. Yeah, it would have been a massive loss.
I have a question people always ask. Is there any expiry date for the pure essential oil?
Not as such, not going bad as you would think. It will never get moldy. It'll never break down into another compound or another. It's very stable the way it is. What it will do is over time, and with oxygen constantly open the lid, it'll get very resinous and tacky until it actually completely dries out. But that takes a long time. Some oils are better resistant to that. Black spruce lasts a long time in a bottle. The pine oils, a couple of years, and you can almost get that lid open. I've got sealed bottles with pine oil in it. It's 2.5 years old. It's crawling out of the lid and down the side of the bottle, and it welded itself to the cupboard. I had to turn that thing off to get it out. There's a prime time to use it, and then after a while, it does start to lose its potency. So, I guess you could say there is an expiry date on it.
So in general,
it's a long
5
time.
years, 10 years?
If you keep it in a cool place, you're looking at 10+ years. It's well sealed out of the sun. It keeps it cool. Don't open and close it too many times. What I'm going to start doing with some of my samples, I'm going to use a tabletop nitrogenizer, generator, and start adding nitrogen to my samples to make them last longer. And it'll go into the bottle, displace the oxygen, seal that bottle, and that nitrogen won't react with anything in there. And so it'll keep it a lot longer.
Do you have a code that actually says when it's like a batch numbers that you know when it was ready? A lot of products, it's actually, when is it made?
The lot number, right?
Yeah.
Yeah. Do you know, whatever product you have?
I'll show you something here.
Okay.
It's really interesting. So these are some of the samples I've already done. This here is one sample of black spruce I did 0754. 0754 is the delivery number on our trucks. So I can go and look at the delivery page, and on there it'll have the distillation data, it'll have the harvest data, it'll have the weather, it'll have the ground temperature, it'll have humidity, time of day, and all of that goes into my result. So 0754 actually starts to encompass my testing, and everything is all grouped together. So if I go 0754, I look at that paper, I know when it was done, the type of day, how long it took to cook, where it was distilled or harvested from. I could go back through the exact site, because each one also has a list of coordinates of where to cut down. We can go to the exact site where they cut the trees down. So if I have anything on here that's out, I just look at that label. And this one here is, it was March 3rd, 2025. It was started at 8:02 in the morning. Batch number is 0756. You go back to that log, you get all the information.
The consumer would not know though. Like
What's that?
the consumer.
No.
No.
No. No, I don't deal with that side of it.
Right.
I'm just trying to get it to you.
Yes.
After they put it in the bottle, ready for sale, yeah.
I think
I mean, it could be done.
the bottle will have a lot number.
Yes.
A lot number.
Yes.
The
Yeah.
bottle.
Lot number
The office will know. It
Yeah.
really need to find out what is something.
in general,
In general, yeah.
In general, yeah. I mean, it is possible you can trace it back, because there is a handoff on every stage of the operation. You just have to know how.
May I ask the GC, is it the GC machine is all the essential oil company will have this machine to test?
I got pretty lucky with that one. That's one of their newest ones. Not everybody has that one. I think there's only a couple of the people that got one of those. They have older models at most of them. We just sent our old one. I used to have it was a Shimadzu, very bare bones, bare bones GC. They bought that used for $15,000. You really kind of have to know how GC works in order to be able to use those, because there's nothing there to tell you what's going on. You just have to know. Trying to learn on that one was absolutely crazy. Holy smoke. I didn't think I was ever going to be able to understand it. We did have problems with that one. We got rid of it. That one's gone down to South America, and that's going to be used on one of their farms as a teaching tool to get them, the new students, into the GC work, how it all works, and then put them into a lab setting. So we're quite happy to give that one away. I did not like that thing at all. This one here is a Cadillac compared to the other one.
Wow.
It's a really nice ride, that one. It's got touch screen, it's got onboard diagnostics. It's a dream to run. Very, very cool.
May I know how much of this machine do you know?
That unit was over $100 and something thousand. The software was over $14,000.
Wow.
The ALS automatic liquid samplers on top, I think, were, you probably get up to $7,000 each. The columns are anywhere from $15,000 to $2,000 each. Yeah, it's a lot of investment going to get one of those started up. If you're going to have one that's very versatile too. This one here also has attachments onto it, and you can reconfigure how the columns work inside, and you can do different kinds of gas chromatography with it. As far as I know, there's an infrared add-on attachment. You can do that, so you get infrared chromatography. There's other attachments that can go on there that you can start doing testing for hydrosols. You don't really want to introduce water or oxygen into that machine, so I can't really test hydrosol with it. But I'm going to need to. We're doing more and more shipping with it, and it'd be nice to be able to test that before it went out the door. So I'm hoping that's going to be my next tool that I end up getting. I'm probably not going to get a mass spectrometer anytime soon. We need to start making a lot of money here to do that. It gets pretty pricey. You're looking at $250,000 there, easy, just on the basic unit. And then there's other ones. Yeah, I'm gonna have to build those myself if I ever want to see one. So having an onboard nuclear reactor is probably going to take me a couple of years. But yeah, we'll get to it. Maybe we'll work it on the weekends.
Well, I guess what Noel wants to know is other brands, do they have this kind of equipment?
They're
It's all like
The plan is to have
Do
all the partner, or not the partner farmers, but all the Young Living corporate farms
Yeah, but
to
like
have access to this.
other essential is this normal for other, like for the whole industry, for essential oil companies to have?
No, they typically rely on a third party.
This is the point.
Yeah, this is the
have their
point.
own
If you're not
system.
able to mass produce and sell your oil, you're not going to have enough money to do this. So you're gonna, the third party is going to get all that business.
Remember to get stuck
Just
traveling
now-
down with
Yeah.
shopping the standard. If you get stuck
So
shopping.
that's another really good point that right there. Is not only is this farm have availability 24/7 to have their testing done, we're not paying thousands of dollars to have it done. So, you know, I haven't opened the lab yet to anyone local to doing any other kind of testing. I'm kind of limited on that, but also don't really need to. I got enough of the research around the farm here to keep me busy for a long time. So this summer is going to be really quite busy. I got a couple of different distillations I'm going to go in and research, see if they're viable at all. I'm going to go and do a bunch more distillations on tamarack and see if I can come up with a viable oil, perhaps for market. There hasn't been any interest in it yet, but that door's still open.
Just now you mentioned about the oil is once it's stable and you store it in a dark place, it's very stable. It's a very long time to expire, right?
Yeah.
But how about the use of the prime time? For example, if you do an analysis of the essential oil and then you measure about certain constituent compound, and would that decrease over time in terms of the percentage or in terms
Good
of the
question.
benefits?
It doesn't.
Oh.
I've tested oil from 5 years ago, and it's only like 0.01% different in a couple of compounds. It might be 0.1% different, give or take, on a couple of others, but it's exactly the same test that I did, and there's no significant difference at all. What was different is the odor was a little bit more muted, so some of that really aromatic compounds that are already gassed off.
Evaporate, right? Or
Like
the
they
mono-
evaporate, they escape, and
Yeah.
they'll collect in there inside whatever air gap you have. Every time you open it, there's a little bit that comes off, so a little bit of its potency is gone. But the constituencies themselves is hardly unchanged. And especially what I haven't seen is one compound breaking down and becoming another, which is my big concern. You don't want
So
to
it
see that.
doesn't.
You don't want to see that kind of degradation. If it was just gassing off and becoming less, that's fine. That's one thing. But as long as it's not becoming something else, yeah, that's fine.
So it's usually the light molecules that are coming out.
Molecules. There's esters. As a type of molecule that has a lot to do with the way we smell and perceive smells. Those can escape, and that's one of the part of the reasons why it becomes so muted.
What is muted?
Muted is not as quite as powerful, vibrant. It just loses energy over time. It's really hard to prevent that, and actually you can't 100%. So, but you can make it last a lot longer just by following that, keeping it cool, dry place, out of the sun, and it'll last you for as long as you need it.
So does it mean that it will smell different, like along the years?
If you take a sample of black spruce that's fresh, does not smell anything like black spruce that's been in the bottle for 2 weeks.
Yes. It's the same.
It's completely different. And if you leave it for a year, it's even different still. So it's what they do before putting it in a bottle. Is a lot of those oils, especially the conifers, are sitting there for a year curing before they're ever put into a bottle. And they get out to its best smell, its best aroma. You get it fresh out of the vat there. You get a lot of phenols and everything, alcohols, light level alcohols. They're all there. It gives you like a musky kind of really punky scent to it. You let that gas off over 2 weeks, it starts to smell a lot more rich, and you start to smell a lot of the pinene. You let it over for a year, and then some of the other limonene, philandrines start coming through. It's a lot more agreeable. Most people find that at that age, the oil is the best.
So is there a general rule for black spruce to like leave to stay until it's out in the market?
About a year.
A year.
Oh.
Yeah.
So you bottle in for a year before you market?
Typically, yeah.
Mm.
Yeah.
That is the prime time to use, or maybe that is ready to use.
Scent-wise, yeah.
Mm.
Yeah. See, it's a lot of it's with the marketing. You have to go with what people prefer. So, like a lot of people here might really think that the fresh coming off the out of the separator is the best.
Mm.
But market-wise, that's just it doesn't work. So, yeah, a lot of it's how people perceive. The other one is if you ever wanted to, it'd be really hard to change the scent of a blend because people are already used to a certain way it smells.
Mm.
And so it's another thing with marketing is the reason why I don't do it because I don't have a refined sense of smell. Like, that just smells nothing like that. Throw that aside, and that'll get picked up by somebody else and say, "Oh, this is amazing. This is actually what you should be doing." It's like, I don't get it. So I don't bother with that part of it. You'll notice here I got some what I like to call typical labware. This is usually what you see when you think of a lab dealing with chemicals is a separate like this, a distillation apparatus. On Friday, I'll get more into this. I'll just demonstrate how it works. But basically, it uses the underlying principle of separation. I use it for recycling my solvents. My solvents have a very low boiling point. I take the solvent back out, I refine it, and I reuse it for cleaning. And I don't use it for calibration like on the other instruments, but for general cleaning, it saves up a lot on environmental, disposal. I've had that set up for almost 2 years, and just in the price of you having to buy solvents all the time, it's already paid for itself. And that's just one of the things I use it for. The other thing I'm trying to do with it, and it's taken a lot longer than I thought, is trying to break down all the compounds and isolate all the compounds in black spruce. I want to have samples of each kind so I can study them separately, how they smell, how they react, their physical properties, get a better understanding of how everything works all together. It's a lot more challenging when you have more than a few compounds in a liquid though. The boiling points go right out the window. The whole thing, you got to split it in half. You got to split each half into half, each quarter to half. Now you have eighths, now you have 16th fractions. And having 42 compounds in there probably means I'm going to have like probably 150 different samples of separations that I have to do in black spruce in order to be able to get their single components. I'm hoping that's the case anyway. It's actually quite a bit more work and takes a lot longer than I thought it would. But again, I'll get back into that on Friday. Does anybody have any questions? I don't want to get it too far into it because I can ramble all day. I love talking about it. I love my job, and I like showing it off, kind of. So anybody there on social media has got ideas of what this lab should have, you can get a hold of Young Living and suggest that maybe he does get a nuclear reactor in here somehow. Help me out. I don't know why I need one. It'd just be really cool to have one. So yeah, I'm going to leave it there then. And we're going to head downstairs and they're going to pass you off to Kevin.